Hey everyone, today we're going to be looking at circle geometry, Theorem 1, and this is how it's going to go. So Theorem 1 says, the perpendicular drawn from the center of a circle to a chord will bisect the chord. So this means that if a line is perpendicular to a chord and it is from the center, it will also bisect that chord. So in a nutshell, in a diagram below, if OM is perpendicular to AB, this means that M1 and M2 are equal and they are equal to 90. Then it means this line segment MB and the line segment AM will be equal. Alright, so it means what we're required to prove is that AM is equals to MB. Then we will start by constructing. We constructed radii OA and OB. Then in triangle OAM, this triangle here, and triangle OBM, this triangle over here, we can say OA is equals to OB, their radii. Then B, we can also say M1 and M2 are equal. This was given in the information above. So they're both equals to 90 and then they're equal to each other. Then OM equals OM. From both sides we have the side OM from both triangles, so it's a common side. That's the reason. Now we've mentioned two sides and an angle, and even though the sides mentioned and the angle is not included because it's 90, then this is the fourth case of congruency. Then we can say that the two triangles are congruent to each other. Reason, right angle, hypotenuse side. So the OB and the OA are the hypotenuse, and we mentioned the right angle and one other side. Then finally we can say AM equals to MB, since the two triangles have been proven to be congruent to each other. Thank you very much. In GeoGebra, I have constructed the diagram for Theorem 1, and right here this is a circle with radius 5. So I just had this so that you can see that the radius is 5. You'll see that when I make AB the diameter, these two will add up to give us 2 times the radius. Anyway, so the theorem was saying that a line from the center to the midpoint of the chord. So as you can see, AM and BM have the values 3,5 and 3,5. So this is dynamic. If I change this, they will change as well. And this is when this value is 4. So it doesn't matter. So I've just decided to do this diagram to show that this orientation doesn't have to be like that. We can take it however, and the theorem remains true. So it doesn't matter where the chord is. If there's a line coming from O to the midpoint of that chord, then it will be perpendicular. So now I know I still haven't shown that it's perpendicular, but I'm going to do that just now. Now what I wanted to show earlier, I said if we bring this all the way to here, then we see that AM equals 5 and MB equals 5, which makes AB a diameter. Okay, now let's show that the angle here is 90 degrees. We'll go to the measuring tool, then we measure an angle, then we pick 3 points, and then there we go. We have our 90-degree angle. We don't have to show this. We see it with the little square here. So this is a 90-degree angle between AM and OB, and it doesn't matter where A and B are, as long as the line coming from the center is going to the midpoint, then the theorem holds. Thank you very much. Like and subscribe and share this with your friends. Comment below on suggestions of what to do next, which video to do next, and I'll happily try to do the video for you. I'll see you in the next one. Bye.